In this video, I'm going to show you how to integrate by substitution. So let's begin. The integral of 3x plus 1 raised to the power of 5 dx. How can we integrate it by substitution? So what we're going to do is we're going to set u equals to whatever that's in the inside. So the 3x plus 1, that's the inside function. So we have integral of u raised to the power of 5 dx. Now I want to integrate it with respect to u, not with x. So what I'll do is I'll take the derivative of u. So du over dx, that's equal to, so now the derivative of 3x plus 1, that will just be 3. And our next step is we're gonna isolate, like solve for dx. So I'll multiply both sides by dx. So I'll have du equals 3 dx. And now I'll divide both sides by 3. Now I have dx equals du over 3. So now we have integral of u raised to the power of 5 du over 3. And now I'll just move this constant to the front. So we have 1/3 of the integral of u to the 5 du. Now I can integrate it with respect to u now. So using the power rule, u raised to the 5, I'm going to add 1 on top, and on the bottom I'll divide by the exponent and then add 1 to it. This gives u raised to the power of 6 over 6, and don't forget to multiply by 1/3 because we had this at the front earlier. So we have u raised to the power of 6 over 6 times 3 is 18, plus the constant of integration. And our last step is to replace u with whatever we had. So our final answer will be 3x plus 1 raised to the power of 6 over 18 plus the constant of integration. Let's try this one. So the integral of x times square root of x squared plus 4 dx. Go ahead and pause the video and try it. So once again, we're gonna let u equals to whatever that's in the inside, so x squared plus 4. So we have the integral of x times square root of u dx. And now I want du and not dx. So what I'll do is I'll take the derivative of u with respect to x. So the derivative of x squared is just 2x, and the derivative of 4 is just 0. And now I need to isolate for dx. So multiplying dx on both sides, I get du equals 2x dx. So then dx equals du over 2x. And now I'll replace dx here with du over 2x. So notice that the x variable cancels out. This is what we exactly want when we're doing u substitution. That's the whole purpose. So we end up eliminating all the x variable and we only integrate it with respect to u. Now I have the integral of 1/2 times u raised to the power of 1/2, because the square root just means raised to a power of 1/2 and 10 times du. So I can just move the 1/2 to the front, and then the integral of u raised to 1/2 du. And now I'm going to use the power rule. So u raised to the power of 1/2, I'll basically add 1 on the exponent and then I'll divide by the exponent. So then this gives u raised to the power of 3 over 2 over 3 over 2. And we have a complex fraction here. So what I'm going to do is I'm going to get rid of this fraction by multiplying by 2/3 and 2/3 on top and bottom. So I'm not changing anything because this and this cancels out. So here the 2's and 2 cancels and the 3's and 3's cancel, leaving us just 2/3 of u raised to the power of 3/2. And don't forget to multiply by 1/2 because we had it right here. So now we have 2/3 times 1/2. That's gonna be 2/6, and then that simplifies to 1/3. So we have 1/3 times u raised to the power of 3/2. Our final answer will be 1/3, and then we replace u with whatever we had before. So x squared plus 4 raised to the power of 3/2 plus the constant of integration. And if you don't like writing your answers in fraction exponent, you can write it like this. So 1/3 of square root of x squared plus 4 raised to the power of 3 plus the constant of integration. Now let's try another problem. So find the indefinite integral of x cubed over x raised to the power of 4 plus 16 dx. So again, we're gonna say let u equals this one, the bigger function. So x raised to the power of 4 plus 16. The reason why I'm doing that is because if I take the derivative of this quartic function, I'll get a cubic function, and then the x's can get cancelled out. So the integral of x raised to the power of 3 over u times dx. And now I want to get du. So du over dx is equal to, so the derivative of x raised to the power of 4, you can just use the powers. So x raised to the power of 4, subtract the exponent and bring down the exponent. So I have 4x raised to the power of 3. So 4x raised to the power of 3. And the derivative of 16 is just 0, so we don't need to include that. And let me just get rid of this. Now I'm going to isolate for dx. So I know du is going to be, multiplying dx on both sides, I get 4x cubed times dx, and then dx equals du over 4x cubed. So I can get rid of this dx. I'll just replace it. I'm just replacing dx with du over 4x cubed. So the x variable cancels out, which is great. Now we can focus on u. Now we have the integral of 1/4 times 1/u du. So I can just bring this to the front. So I have 1/4 times the integral of 1/u du. And the integral of 1/u is just going to be ln with an absolute value of u plus the constant of integration. And earlier we said that u is equal to x raised to the power of 4 plus 16. So we'll put it back. 1/4 times ln with an absolute value of x raised to the power of 4 plus 16 plus the constant of integration. And we can actually do a little cleanup here. Notice that x raised to the power of 4 plus 16 is always positive. So we can just get rid of the absolute value sign. So I have 1/4 times ln of x raised to the power of 4 plus 16 plus the constant of integration. And this is the indefinite integral of this function. Now let's try something trig. So find the indefinite integral of 6 cosine of 7x plus 1 dx. So again, we're going to use u substitution. So let u equal whatever that's inside here, the cosine. So let u equal 7x, and du over dx equals, so the derivative of 7x is just 7. So now I have the integral of 6 cosine of u times dx plus the integral of 1 dx. I just separated the integral because there was a plus sign here. And if you see a plus sign, you can always separate it. And now I'm going to solve for dx here. So du equals 7 dx and dx equals du over 7. So I'm going to replace this. So du over 7. And this is equal to, I can just move the 6 over 7 to the front. So I have 6 over 7 times the indefinite integral of cosine of u du plus the integral of just 1 dx. And that equals 6 over 7. And the indefinite integral of cosine u is just going to be sine u plus the integral of 1, that's just going to be x using the power rule, plus the constant of integration. And now we're just going to replace u with whatever we had. So u was equal to 7x. So our final answer is going to be 6 over 7 times sine of 7x plus x plus the constant of integration. And that's the indefinite integral of 6 cosine of 7x plus 1. Now find the indefinite integral of x times e raised to the power of x squared plus 2 dx. So again, we're gonna say u equals whatever that's inside, so it's gonna be x squared plus 2, and du over dx is equal to the derivative of x squared, which is 2x, and the derivative of 2 is just 0. So that's equal to the integral of x times e to the u and then dx. So I'm going to solve for dx. So du equals 2x times dx, and then dx equals du over 2x. So I can just replace this dx with du over 2x. So the x variable cancels, which is what we want. And now we have 1/2 of the integral of e to the u du. This equals 1/2. So we know that the derivative of e to the u is just e to the u. So that means the antiderivative is just going to be still e to the u. So it's e to the u plus the constant of integration. And now we're just going to plug this back in. So our final answer would be 1/2 of e to the power of x squared plus 2 plus the constant of integration. Now try this. So find the indefinite integral of 2x minus 9 dx and try it for yourself. So this time we're going to say u equals 2x minus 9, the inside function, and then du over dx, that's going to be the derivative of 2x is just 2, and then now we have the integral of cube root of u dx, and now I'm going to solve for dx. So dx is just going to be du over 2. So I can replace dx with here with du over 2. And the cube root of u, that's just going to be u raised to the power of 1/3 du over 2. And I can actually put the 1/2 in the front. Now I'm just going to use the power rule. So I have 1/2 times u raised to the power of 1/3 plus 1 over 1/3 plus 1. So then I have 1/2 of u times, so 1/3 plus 1/2 is just 4 over 3, and 1/3 plus 1 is 4 over 3 again. And now what I'll do is I'll multiply both the top and bottom by 3 over 4. So the 3's and 3's cancels and 4's and 4 cancels. So now I have 1/2 times 3 over 4, which is 3 over 8 times u raised to the power of 4 over 3 plus the constant of integration. And earlier we said that u is equal to 2x minus 9, so we'll just plug that back in. So our final answer will be 3 over 8 times 2x minus 9 raised to the power of 4 over 3 plus c. And if you don't like leaving your answers in fraction exponent, this is just going to be 3 over 8 with the cube root of 2x minus 9, and then you raise it to the power of 4 plus the constant of integration. Let's try something harder. So find the indefinite integral of 1 over cosine squared x times sine x over cosine x plus 6 plus x. Before we do anything, let's just clean this up. This is same as the integral of 1 over cosine squared is secant squared x. And now square root of sine x over cosine is tangent x. So tan x plus 6. And then we can also separate the integral here, x dx. And now what we want is let u equals tan x plus 6. That's the inside function here. If you take the derivative of tan x, so du over dx, the derivative of tangent x is going to be secant squared x, and the derivative of 6 is just going to be 0. And let's solve for, and I forgot to put a dx here. So we'll multiply by dx on both sides. So du equals secant squared x dx. Then dx equals du over secant squared x. Now this is going to be the integral of secant squared x with the square root of u, and we know that dx is going to be du over secant squared, so du over secant squared x. And this is perfect because we cancelled out the secant squared x. Now we only have the u variable plus the integral of x dx. Let me just get rid of these. So what we're now left with is just the integral of square root of u is just going to be u raised to the power of 1/2 du plus the integral of x. We can just use the power rule, so it's x raised to the 1. We'll add 1 and then we'll add by the exponent on the bottom. So this is just going to be x squared over 2. And now this is equal to, so the integral of this, we're just going to use the power rule. So u raised to the power of 1/2 is going to be plus 1, and then we'll divide by the exponent. So we get u raised to the power of 3 over 2 over 3 over 2. This becomes 2 over 3, u raised to the power of 3 over 2. So now we have 2 over 3 u raised to the power of 3 over 2 plus x squared over 2. Now let me get rid of this. So now for our final answer, we're going to replace u with tangent x plus c. So our final answer will be 2 over 30 times tangent x plus 6 raised to the power of 3 over 2 plus x squared over 2 plus the constant of integration. And those who wants the answer in radical form, then it will be just 2/3 times the square root times tangent x plus 6 raised to the power of 3 plus x squared over 2 plus the constant of integration. So this is the indefinite integral of this function. And I hope this video helped you, and please subscribe to my channel. Thanks for watching.